More population proportion questions. 1,000 voters, 690 said they voted. So P is equal to 0.69. 1 minus P is equal to 0.31. So 1.96 by the square root of 0.69 by 0.31 divided by n, which is 1,000, is going to give me a value of 0.03. 0.03. That's 1,000. So we are going to say that 63% is what we're looking to see based on our survey. 69%, 0.69 in the middle. So we're going to have 0.72 and 0.66. So our 95% confidence level for this population proportion is that between 0.72, 72%, and 0.66 were the amount of people that voted. So are the survey results consistent with the actual voter turnout? We can say no here. That's not what we see. 0.63 is outside what we would describe as it's outside this interval. That's question 3. Question 4, an insurance company checks Garda records on 500 randomly selected car accidents. N is 500. And notes that teenagers are at the wheel. Bold teenagers, and 82 of them. 82 out of 500 is 164 out of 1,000. 0.164. So that's my P. 1 minus P is equal to 0. I'm going to have to add 836. So 1.96 times the square root of 0.164 by 0.836 divided by n in this case, which is 500, is going to give me a value of 0.03 again, just double check that. 0.03 it is 245. 0.0324. I'll just take the first two. I don't think it's going to make a big difference. 0.3. So we are asked to construct a 95% confidence interval. So we had 0.164 teenagers for P. So if I add 3% onto that, I'm going to get 0.194. 0.194. And 164 will bring me back down to 134. So that's my 95% confidence interval for the proportion that we were dealing with. And explain what your interval means. Well, that we can say that with 95% confidence, between 13.4% and 19.4% of the drivers stopped by Gardaí will have teenagers behind the wheel. And you would obviously write those words because the examiner can't hear your thoughts. Gregor Mandel, who lived in the 1800s, is usually considered to be the founder of modern genetics. How cool is that? When Mandel conducted a genetics experiment with peas, one sample of offspring consisted of 428 green peas and 152 yellow peas. Well, 428 and 152 is 580. So what are we asked? Find a 95% confidence interval for the percentage of yellow. So my yellow, or my 152 out of my 580 is going to be my success. And 152 divided by 580 is 0.262. So the probability, or 1 minus P, we can say I'd have that 738, 0.7 0.38. So 1.96 by the square root of the probability of yellow pea is 0.262 based on our sample or our proportion by 0.738. The probability of not getting a yellow pea in our sample divided by the size of the sample, which is 580. So 1.96 by that is going to give me 0.036, 0.036. So 0.262, 0.298 is going to be at the higher end, 0.298, and at the lower end it's going to give me I'm going to take away 36, so I'm going to 26, so 0.226 is going to be my 95% confidence interval for the amount of yellow peas that we will get based on Gregor Mendel's experiments. Based on his theories, Mandel expected that 25% of the offspring peas would be yellow. Given the percentage of yellow, do the results contradict Mendel's theory? Well, no, because 25% Mandel was bang on. It's pretty much close to the middle of our band, so Mendel's predictions were pretty fit for purpose.